I'm Jason Whitus. I'm from SeaLights, and I'm going to be talking to you today about deploying your code to production without using a gut feeling, knowing what the quality is of the code before you deploy it into production. It means that you need to have the visibility to understand what the quality really is of your code. What I'm going to be talking about in the beginning is the changes that are happening in our market, in the whole development world, what we currently are looking in regards to quality, what I think is missing, and how to receive that feedback into the system like Jenkins. So in the end, we can deploy the code into production with our eyes open and, as I said, without a gut feeling. As long as we have enough time, I'll show you a short demo of how it can be done, and finally take questions. So let's look at the changes in our market, and people have talked about it already today. But the main changes are we're moving from one big application, which we deploy once every week or two, to small applications, small microservices that we're deploying multiple times a day. If we're talking about also mobile phones, you get updates automatically. Things are moving all the time. This means that the frequency that our build system needs to build, test, and understand that things are working correctly has gone up tremendously. Another change are our team structures. If we used to have teams which were separate, each one in charge of their own responsibilities, you had the development team, the QA team, configuration management, DevOps, and so on, not really caring about the other team. They just pass it on. You know, QA will test my code for me, CM and DevOps will build the code for me, and therefore they don't really care what's happening to their code. They're not in charge of it. What's changing today is that we're turning into smaller groups. They're cross-functional. They're doing everything on their own. They're moving the code from the development all the way through to production. They're in charge of everything, including code, including quality, writing tests, and handling everything. Now, this is awesome. The problem is that it comes at quite a bit of a cost. This is what our applications look like. Lots of decoupled microservices, different data sources, queues, gateways, caches, and so on. A single service can be updated on its own, not the entire application. It creates a challenge for testing, for gathering all the different metrics from all the different microservices, understanding really what the overall quality of our product is. Another thing is that each group has their architects, has the developers, and those developers read up some kind of hip language or something new in the market, so they decide, okay, we're going to develop in this language or in that language, and you start getting different languages that you need to handle. Jenkins does a lovely job for us, building all the different items, but again, each one, you need to be able to gather the different metrics. This, for instance, is a screen capture from Wikipedia regarding Java. I don't expect you to read it, just to get an idea of the different testing frameworks that you have for Java. Each group can select a different type of testing framework that he wants to work with. The ones in green are the ones that put out, for instance, a JUnit XML, which Jenkins also knows how to show. But as you can see, there's a lot of them out there that don't put out the JUnit XML. If we look at JavaScript, it's even worse. And that's because in JavaScript, not only do we have server-side code, we've also got browser-side code. And how do you capture coverage from browser-side code? And some of them do put out JUnit, but you've got other technologies as well, and other type of reports. So with this whole mess comes DevOps. And DevOps does a wonderful job using Jenkins and other tools like it. But I'm not here to talk about DevOps, because that can be a complete day to talk about it. And in DevOps, we've got the whole CI/CD program, making sure that we can build everything and streamline everything all the way through into our production, running through quickly. The problem is that the amount of time that we have left for the testing is dropping, and the amount of time that we have to decide whether our code is of good quality means that it has to turn into something that's automated. It has to become metric-driven, something that we're going to be measuring. So, because we don't always know what we're deploying, if it's going to break or not, we have to be able to capture the different metrics. There are companies, for instance, that take their code and throw it directly into production. They're usually web-based companies, service providers, and they've got a small group of, you could say it's sort of like beta testers, and if it works with them, then they'll open that feature up for the rest of the customers. A lot of us cannot do that, and even when you do that kind of thing, it's your reputation. If you put something into your customers that's going to break, it's your developers that are going to wake up in the middle of the night, it's the DevOps guys that are going to wake up in the middle of the night, and the reputation of the company. So let's look at the metrics, okay? The metrics in green are the ones that virtually everybody has today. And that's looking at the binary decision of whether a test passed or failed. And obviously, if a test passed, it means your code is good. The question is it testing what it should be testing? The second thing is that what's being looked at is the coverage, but that's mainly being looked at on the unit test level. Now, take this for example, coverage on the unit test level. Each item is being tested on its own. It can have 100% coverage being tested perfectly, but the problem is as soon as you put them together, what's going to happen? One of them is not going to exactly work the way it's supposed to. And therefore, unit test coverage is just not enough. What you need is coverage on every single level. So as you can see at the bottom, that's what most companies have today and most teams have today. Unit testing running automatically. They've got tools providing the coverage automatically, like Sonar, for instance, or Jacoco, and so on. But what is your coverage on the other test stages? You've got all the functional API, integration tests. You've got the browser, the UI tests, and even manual tests. A lot of these tests, the automation tests, are very difficult to do, and there's companies that mix the two together. You've got also the automation tests, and they're still doing a bit of manual tests. But how do you know? It maybe you're retesting code that's already been tested. If you don't know how to measure your coverage in every single one of these levels, then you don't know what's really being tested and what's not. But now, if you can take and monitor the amount of code changes that you're making to every area in your code, and you can take the coverage information and you can mix the two together, you can now understand exactly where your highest risk is. And the highest risk is where you're making the most amount of changes and your coverage is the lowest. That'll allow your teams now to invest in creating those quality tests, integration, API, UI, and so on, where it actually hurts, where it actually will make the highest effect. And the code, for instance, legacy code, which is sitting in production for a long time, you don't really have to invest tests over there because it's been running for a year. It's going to probably continue running. So you need to be able to pinpoint where your highest risk is in order to invest your time correctly. There are what we call quality risks. Quality risks are not only where you're making your code changes and not covering them, but if you're making code changes and you're not covering them in any one of your environments, what's going to happen is that those code changes are going to go into production. And then the person who's going to be testing it for the very first time is your customer. Therefore, this is one of the highest, riskiest areas which you should be looking at. One of the most important metrics, okay? Because if it's not being tested, it'll most likely fail. Another thing is test quality. I'm sure a lot of you have encountered situations where people have written tests just to write the test. They've got Sonar set up, and they want 100% coverage because the CTO said, well, we have to have 100% coverage, and the developer is in a hurry to get home. So what does he do? Writes a test that'll just say everything's okay. So now he's got 100% coverage, but it's not really testing anything. Therefore, another metric that you've got is what's called test quality. There's tools that handle that. There's, for instance, what's called mutation testing. What that does is it plays around with the code and checks if the tests will fail or not. If they fail, it means the tests are written correctly. If they don't fail, there's something wrong with your test. There's a test duration. You've got a pipeline, it's running, you've got your tests running all the time. If you're not monitoring the duration, suddenly those tests might be taking longer than they have up until now. And this could mean that you've got some kind of performance issue in your code that you're not even aware of. The code's working correctly, there's no bugs per se. But just looking at the duration, you can understand your performance issues. There's what's called test stability. If you've ever heard of flaky tests, you can have a test running on the exact same tests, on the exact same code, on the exact same configuration. You run it and it fails, and you run it again and it fails, and you run it a third time and suddenly, oops, it passes. Does that mean your code is okay now? Just because the test passed? You need to be able to monitor what's happening with those tests along its life cycle to understand if those tests are trustworthy or if they're flaky. Which brings me to the history. So as I said, for all these different metrics, what you need to be able to do is to have the history of your pipeline, of the tests, of all these metrics. So you can monitor them, so you can see the duration changes, so you can see what you're looking at. But if already you've got the history, the very big advantage that you have here is that you can mark which build you currently have in production, and then you can compare those metrics to what you have in production. You're not comparing them to the one build back. So let's say in production, you've got 70% coverage. Then you started running and building code and so on, and it dropped down to 50% coverage. But now the latest build that you built picked up to 60% coverage. So you say, wow, I went up from 50% to 60%. That's great, but not really, because in production you got 70% coverage. Only with history, only with looking at every one of your builds and monitoring them and keeping track of all this information, you can really understand that what you're deploying into production, what the pipeline that you're working on will be putting into production is really of good quality, is only by having the history as well. Now, you've got all that, but there are other information. For instance, you've got Jira or any other defect management system. What happens if you've got a high severity defect there? Your tests aren't picking it up, but if you've got a high severity system, do you want your systems to automatically put this code into production before someone's actually looked at that high severity defect? And therefore, if you can put also into your metrics, receive those custom metrics into your system and provide that feedback to Jenkins, another indication of whether your quality of your code is high enough or not in order to deploy into production. So, from my point of view, you need to be measuring every kind of metric for every kind of microservice and for every type of test that you have. You need to store it, you need to compare it, so you can pinpoint the issues, have a clear understanding of what's going on. And why is that important to the DevOps? You can say, well, you know, it's QA's problem, it's dev's problem, but no, it's the DevOps problem as well. Because when the code's going to fail, when something's going to go wrong in production, one of the first people that they're going to wake up is the DevOps guy. What's happened here? And then he's going to start looking into it and understand what's going on. Oh no, that's a problem of the developer, and now we need to wake up the developer, and so on and so forth. So if we have a clear system of what's going on and we can add it to the pipeline, to Jenkins itself, we can eliminate as much of these issues as possible. Obviously, we'll never get to 100%. What can you do? We live in the world of code, but we can at least bring that down to a minimum. And therefore, what we need is one type of central dashboard, one central area where we can bring all that information to, bring it into one place, and create what are called quality gates. And on that dashboard, set what are the thresholds that I want in order to say that my defect is sane or not. That way we can also view there what's going on, we can see the trends, we can see the information and not run after a job over here in Jenkins and a job over there that's running on a different type of pipeline and a different type of testing system over there with their reports and so on. So these are the metrics that I think you need to be implementing in your systems, not relying on the gut feeling to understand whether your code is really of high quality or not, providing the teams the knowledge of how to improve, how they're progressing, really what's going on with the code. But now what? How do you stop it from going to production? Well, if you have that kind of dashboard, you have the quality gate set up, you have the information all set up, one centralized place to have that information, you can now take that and feed it back into your CI/CD system. You can now provide feedback of what the quality is and have the build fail if something's wrong. And you can have Jenkins, if it's monitoring the commit changes, send emails directly to the developers saying, well, look, there's something wrong, we failed your build, we're not deploying to production, here's the reason why, please fix it. So, with this kind of setup, you set it up, you can deploy with your eyes open, without a gut feeling, you can know the quality, what it is, not waking up in the middle of the night again, not handling these things that people have put in that you have absolutely no knowledge of what's going on. But, as I say, practice what you preach, and therefore, I'll show you a short demonstration of how I've set it up on my lab. So what I have here is a Jenkins job. You cannot see it. Oops, 1 second. Sorry about that. Now you can see it? Okay. So what we have here is a Jenkins job which I've set up. And what it's going to be doing is I'm going to be running manual tests, which you can say, okay, how can I run manual tests and provide information about it? But even more than that, I'm going to measure the coverage from the browser. The way I'm going to do that is I've set up a parameter with the amount of time that I want it to stay alive. In this case, because I'm talking to you, it'll be only 60 seconds, but in the real world, it can be open for a few hours that you're providing the quality team time to do their manual tests. I'm working with a project which exists in GitHub. It's called To-Do MVC. It's an open source project for managing to-do lists. But of course, this could be any project you like. What happens in my lab is that the first thing that I do, I've got an agent under Node which goes and scans that code. And when it scans that code, what it's doing for the browser side, it's instrumenting the code, and it's placing inside that code extra bit of information in order to capture the coverage. So now when that code goes to the browser, and Chrome in this situation will be downloading the JavaScript files into it, it will have the extra code there to provide the coverage. So first I instrument the code. I'm going to be putting that code instead of the original code. Okay, so I'll be deploying it, and that will be the same as when you deploy your code onto a server. Then I'm going to be sending my lab a start event, which that says that the tests are about to begin. I'm going to be bringing up the server. There's another small open source project called HTTPster. It's a small node project. What it does is that it brings up a server based on the index.html that you have in a certain folder. Then when I'm browsing to there, I'll be able to capture the coverage. I'll be going to sleep for 60 seconds. Now this is a little trick I learned in Jenkins. What happens in Jenkins is that if you run a service and that service at some point dies, Jenkins thinks that something went wrong and it'll fail your build. So if you want to bring up your service without Jenkins dying, what you do, and this is taken by the way from Jenkins' site, so you can see it there as well, you change what's called the build ID. Jenkins monitors the build ID to know whether your process belongs to it or not, and whether if it dies, something's went wrong. So as soon as you change that build ID, and here I've changed it to don't kill me, but it can be to everything and anything you like as long as it's not your normal build ID, as soon as you've changed that, Jenkins stops monitoring it. So now I can run it in the background, and in Unix that's with the ampersand symbol. That means that my service is going to come up, and I'll be able to continue working. I'll be going to sleep for 60 seconds, and in the end I'm going to kill that server, which again would normally kill my Jenkins job as well. Finally, I'm going to be creating a small little JUnit report. Because it's manual work, obviously, this cannot be done automatically. Uploading the report into my lab and sending the end event. The final step, which is what's important here and what I'm talking about, is that through an API to my lab, I'm going to go and ask what's happening with that build. Is that build now of good quality or not? Based on that, I will now decide whether I can deploy into production. Now, because I don't really have a proper production here, I'm just going to be putting out a message which says either you can deploy it to production or you should not deploy it to production. Okay? Now, obviously, in the real world, even if something like that would fail and I'd still want to deploy to production because I have to and I'm willing to take the risk, you can always implement that into your Jenkins lifecycle as well, an override. This is just for the demonstration. Finally, another little trick in Jenkins that I did is I want to differentiate between when I build my job here, that the build is failing because of a real issue, or it's failing because, for instance, over here I should not be deploying into production. And therefore I want to mark it as unstable if I shouldn't deploy it to production. The way I found it to do it, there's a nice little plugin called Jenkins Text Finder. And the Jenkins Text Finder, what it does, exactly what it says. It searches for text. In this case, I've marked that I'm searching for the text in the console output. You can also search for the text within files. And if it finds that text, it's going to set it as unstable. And therefore, if my quality is good enough, I'll have it passing. If my quality is not good enough, I'm going to have it unstable. And if something really catastrophic went wrong, I'll be able to see that because my build will actually fail. Okay, so let's have a go at this. And let's have it run. So we'll give it the 60 seconds. Okay, so while it's running, it's supposed to come up on port 333. So as we can see here, this is dead. And what we're actually waiting for is it to get to that point. Now in the meantime, what I'm talking about my lab, this is the lab that I've set up. This is the project that I've set up. Currently it's build 34. What I'm currently now building is build 35. Okay? And it looks like we might have an internet issue. But we'll see in a minute. Yep, unfortunately, the internet is not working. And as my lab is based in AWS, that's kind of important. Oh, it seems like it's working a bit better now. Okay, so there it goes. Now it's instrumenting the JavaScripts. Okay, sending the start event, as I said, and bringing up the server. So now if I go back to that page, refresh it, here I can see the project came up. I can now make a number of changes, play around with it, be my own QA. Okay. And what will happen is if I go back to the dashboard and refresh over here, I will see it's already receiving the coverage. So I have 83% coverage from what I've been doing. It's still great because it hasn't sent the end event yet, which will happen within 60 seconds. Then this will be marked as green or as red. I can have a look at the history of things that were done in the past. And finally, that information will be fed back into Jenkins to decide whether that is sane or not. Here we've finished the 60 seconds. So I can go back to here. Obviously, if I refresh, it's no longer answering. And finally, it's now going to be asking the lab what's going on, is it sane or not, and whether I should be deploying into production or not. Now, this was set up with my lab, but you can be setting it up with a number of tools that are out there. There are all different tools that can be used, whether it's Sonar, Sonar Cube, Jacoco, and a number of other things that have come out. Here we can see the message, by the way, build quality status pass, you can deploy to production. If I would have not done the tests, they would be low, therefore it would have failed, and I shouldn't have been deploying into production. So I urge you to take these metrics, implement them into your pipeline, use the correct tools for what you need for your technology stack, make sure that things are being implemented correctly into production. Any questions?